Hello everyone. So this is a question from JEE Mains 2026, 6th April Shift 2. The correct order of first delta iH1 and second delta iH2 ionization enthalpy values of chromium and manganese are. Okay. So these are some options. The chapters involved is classification of elements and periodicity in properties and DNF block. Okay. So the energy required to remove the most loosely bound electron from the isolated gaseous atom, that is known as its first ionization energy, okay, and it is denoted by delta I H1. Okay, with respect to reaction, I can write Mg plus delta I H1 is giving me M plus G plus an electron out. Okay, so this is the ionization enthalpy or ionization energy required to remove an electron out from an isolated gaseous atom to give us the M plus cation. Okay, similarly, energy required to knock out second electron is called the second ionization energy or enthalpy, and it is denoted by delta iH2. That is, with respect to reaction, M plus gas plus delta iH2 giving me M plus 2 gas plus electron. Okay, so the energy required to knock an electron out from the M plus cation to give us the M plus 2 cation is known as delta iH2 or the second ionization enthalpy. Okay, so in the question we have to determine the order of delta iH1 and delta iH2 of chromium and manganese. For that we have to know their electronic configuration. That is, for chromium it is 3d5 4s1, for manganese it is 3d5 4s2. Okay, so let's first talk about their delta iH1. Okay, so obviously we have to knock the outermost electron out. So here an electron from 4s goes out, here also an electron from 4s goes out. Okay, the delta iH1 of manganese is more than delta iH1 of chromium. Okay, because in manganese we have to remove electron from a completely filled 4s orbital, which requires more energy. Okay, that's the first reason. And the second reason is Mn also has more protons because the atomic number of Mn is 25 and the atomic number of chromium is 24. So therefore the nucleus of Mn pulls the outermost electron more tightly. Therefore more energy is required to knock an electron out in the case of Mn. That's why its first ionization energy is higher compared to chromium. Okay, and also chromium has low first ionization enthalpy or ionization energy because loss of one electron in the case of chromium gives us a very stable configuration of 3d5. Okay, very important. So I will write down the reasons. First is in Mn, so we have to remove electron from completely filled 4s. Second reason is Mn has atomic number 25, so more protons than chromium, whose atomic number is 24. So therefore the effective nuclear charge will be more in the case of Mn. And third, chromium has low because loss of one electron in Cr results in 3d5, which is exceptionally stable configuration. Okay, cool. After they have lost one electron each, that is manganese has lost one electron, chromium has lost one electron, they become Cr plus and Mn plus, and their configurations are important. So Cr plus and Mn plus. configuration of Cr plus is 3d5, configuration of Mn plus is 3d5 for S1. Okay, so here we have to knock out the next electron from a 3d orbital. Here we have to knock out the next electron from a 4s orbit. And the delta iH2, or the second ionization enthalpy of chromium, is greater than the delta iH2 of manganese. Okay, because after removal of first electron, chromium has acquired a very stable configuration of 3d5, and the removal of second electron or the next electron is very, very difficult. Okay, so tough to remove electron from Cr plus due to 3d5 configuration. And Mn has low second ionization energy. It has low value because loss of one more electron in the case of Mn plus gives a very stable configuration of 3d5. Okay, so Mn has low delta iH2 because loss of one more electron gives stable configuration of 3d5. Okay, so therefore out of the four statements, statement B is correct. That is, the second ionization energy of chromium is more than manganese, and the third statement C is correct. That is, the first ionization enthalpy of manganese is more than Cr. Okay, so these two are the correct options. Okay, thank you.